My name is Princeton Perry, and this is homework 7. In this homework, we were instructed to create a 4-bit shift register that has the following capabilities. It can shift to the left, or it can have its contents cleared. It can shift to the left. It can rotate its contents to the left. And then for our 4-bit counter, we were to make it so that it can have its values reset to 0. It can increment by 1. It can increment by 2. And then we were to create a state machine that will clear the register and reset the counter, perform some action on the register that we decide, perform some action on the counter, perform a different action on the register, perform a different action on the counter for separate states. So we look at our VHDL. We have our counter that is with our clock and reset imports. We also have our action C. This is our counter action, or the action that the counter would receive to know what to do, as well as our output that will be outputted from our top level. And we go into our process here. We see that we have our clock cycle. It resets 1, then temp is reset. So that's how we're resetting our counter. And then for the incrementing, we have when 0, 1 is detected, we will increment by 1 here, or our temp signal will be incremented by 1. And when we detect a 1, 0, we'll increment by 2. If we are not detecting anything or anything else other than that, we should hold our temp value. So then we see here in our shift register our inputs and outputs, our clock clear, and our register action, as well as our input value, in which we're going to be loading into our register in our original state and our initial state, as well as its output as well. They'll be routed to the top level. We see here our clock cycle, and when 0, 0 is detected, then our temp signal would be, our input will become our temp signal. So that's how we're loading our value. And with that loaded value in the next state, when we're detecting 0, 1, we will shift to the left. And then when we're detecting 1, 0, we will rotate our value to the right. So we see that there. Then when others, our temp signal should be the same. We go to our FSM. We just see our process here again. So we have our inputs, reset and clock, as well as our 2 actions that are sent to our register and our counter. We have our process, our signals, our current state and next state, as well as our process for our clock cycle and a reset. And then when 0, 0, 0, when we're in initial state, we should load our value. Then our next state is 1. When then we're in our next state, we would perform our first operation. When we're in the state following, we'll perform an operation that will be sent to our counter. Our first operation that will be sent to our counter. When we're in the state that follows that, we will perform another operation for the register, our shift register. And then when we're in our last state, we will perform another operation for our counter. So then when others, our next state should be 0, 0, 0, in case and process. So going on to our simulation, we see here that in our original state with the reset press, everything is at 0. On the rising edge of the clock, we will load our value to our register, and then when we continue on, we perform our first operation, which is our shift left and our register. If we keep moving forward, on the rising edge of the clock, we will perform our first operation in for our counter, which is incrementing by 1. Our register moves, it continues to move to the left because it's still in that state. So it's still moving, shifting to the left. Then we see that our output for our register will now rotate right on the rising edge of the clock. And our output for our counter is continuing to increment because, again, it's still in that state. And then for our register, our output is 0, 0, 0 now. And for our output C, we see that we are now performing the second operation, which is incrementing by 2 for our counter. And then we reset our values again and it continues on. Okay, thank you.